Dear friends, psychrometric chart is a useful tool to understand the properties of moisture, and it is in a way a representation of the properties of moisture in the chart form. Okay, we know that the properties of moisture can be represented either in the form of tables, which are known as psychrometric tables, or properties of moisture, or they can be represented in the form of a chart, which is called as a psychrometric chart. So the psychrometric chart typically looks like this. So let me draw a psychrometric chart. This is the horizontal axis where you have the dry bulb temperature mentioned. This is the vertical axis where you have the specific humidity mentioned. Then you have a construction like this. This curve which I am drawing is called as a relative humidity curve or saturation curve. The relative humidity of this curve is 100%. So this is 100% RH curve, or it is also called as saturation curve. So parallel to this, or the curves below this, you would have different values of RH. As you move downwards, for example, you would have lower values of RH. The wet bulb temperatures, they are represented like this, and they would coincide with the specific enthalpies. Almost coincide. There is something called as enthalpy deviation, but that we will not discuss. So if you want to, there are other lines like specific volume lines and so on, but my purpose here is to explain you how this chart is useful for understanding the various psychrometric operations that take place during air conditioning. Now, air conditioning, you all know, is basically about changing the parameters of moisture, and changing the parameters means basically changing the temperature and changing the. So air conditioning, we know that it is about changing the temperature and changing the moisture. So if it is a cold country, like a European country, there you might be interested, and European country, you might be interested in changing the temperature, increasing the temperature. If it is simply increasing the temperature, then you need to basically carry out a process like this. You want to increase the temperature. So only increasing the temperature means a process A to B, and that process A to B would be then called as sensible heating. Sensible heating. If you want to increase the temperature as well as humidity, then it would be increasing the temperature and humidity means like this, and the process would be A to C. So that process A to C would then be heating and humidification. Heating and humidification. Okay. Now, suppose it is a dry climate. Let us say that you are talking about a place like Rajasthan, okay, or a dry city, right? Any city like Malegaon, for example, in Maharashtra. So there, for air conditioning, you would be interested in increasing the moisture content and decreasing the temperature. So if dry climate, when you are talking about dry climate, so in the dry climate, you are supposed to decrease the temperature and increase the moisture content. So which process is then recommended? So in that case, if you want to decrease the temperature, so decreasing the temperature means like this, you are decreasing the temperature, and increasing the moisture content means like this. It means the process would be then cooling and humidification. So for a curve like AB, so a curve A to B is cooling and humidification, which would give you the desired comfort condition. Okay, so this is recommended in a dry climate, cooling and humidification. Okay, so this psychrometric process A to B would be recommended in a dry climate. And you know that desert coolers, for example, or evaporative coolers or simply coolers, they basically perform this kind of operation, evaporative coolers, right? Now, if it is a humid climate like say Mumbai, in that case, if it is a humid climate like Mumbai, in that case we need to reduce the moisture content. Okay, so a humid climate would not need increasing moisture content. You need to reduce the moisture content, and in that case, let me then explain you here. The temperature has to be reduced. We are talking about summer air conditioning, and the moisture content also needs to be reduced. So the psychrometric process would be different. So what we would be aiming for is reducing the temperature. The temperature has to be reduced, so there has to be a cooling, and the moisture content has to be reduced, so there has to be a dehumidification, and the psychrometric process would then be a cooling and dehumidification kind of thing. So A to B would be the psychrometric process, which is cooling and dehumidification. And if you want to achieve this cooling and dehumidification, your AC systems like split AC system or window AC system or even a central AC system can be employed, where you need to cool the coil, cooling coil, below its dew point temperature, and then you will get a cooling and dehumidification process, and you get a comfortable indoor conditions. Okay, so this is how a psychrometric chart can be useful in designing the air conditioning system. The psychrometric chart is available at a standard atmospheric pressure, that is at the atmospheric pressure at the sea level. Okay, standard atmospheric pressure. If you want to get the properties at a different pressure, the pressure is much different from the atmospheric pressure, standard atmospheric pressure, then you need to refer to the different charts. You need to employ different charts, or you can make use of some other tools like steam tables and so on. Okay, so this is the introductory aspect of what is known as psychrometric chart, and how to make use of psychrometric chart for plotting different psychrometric processes and designing the air conditioning system.